All right, so we are now recording our launch from Flutter Chicago for accessibility, our accessibility call today for Disability Pride Month. And today we have Hannah Jin from the Flutter framework team. Thank you so much, Hannah, for joining us. And Hannah, take it away.
Hi, everyone. I'm Hannah. I work at Google for the Flutter team, and I actually joined the Flutter team for almost 4 years now. And I work on the framework team, but I have a main focus on accessibility. So today I will talk about Flutter accessibility and how the Flutter framework code base works. Okay, I will start sharing my screen. Okay. Can you see my slides? Can you give me an emoji thumbs up if you can see my slides? Oh yeah, thank you. So today I will first talk about accessibility requirement and what we want to achieve, and then I will talk about Flutter code base. For this part, I will talk about Flutter framework code and platform code and platform communication between framework and platform. This is important for Flutter because we are like a multi-platform framework. And then I will talk about accessibility testing and our workflow for accessibility. So I'll start by saying why accessibility matters to us. I think for Flutter framework, accessibility matters to us because it matters to app developers. It matters to our clients. So of course there is a moral and legal reasons, and there are a lot of global requirements, especially in Europe. And there are business advantages. It's very important to be inclusive in your apps and to reach more audience. Okay, first I will just mention all these accessibility standards. The first one, EN. Somebody raised their hand. Yeah, you can continue.
Oh yeah, sorry, Hannah. It's just that there is like the dialogue box that is covering
Okay.
the slides a little bit. So if
Oh yeah, I think
if it's okay. Yeah, there you go. Yeah.
I think I will just, instead of sharing my whole screen, I will share this tab.
Yeah, that would be great. Thank you so much.
Yes, yes. So you will not see the Google Meeting dialogue here. Thank you. Yeah. So I was first start talking about some accessibility standards. So the EN one is like a EU standard for web. WCAG is also a standard for web. So accessibility standards are usually more mature on web than on mobile. And VPAD is like the EM1, but they are mainly focused on the US. And then I will talk about what kind of thing does this standard usually cover. There are usually like two parts of accessibility standards. Some part of them about UI design and styling, and another major part about it is assistive technologies. So I will talk about UI design and styling first. There are some main features we need to care about, things like text contrast. So basically, if the color contrast ratio is too close, then it will hard for the user to read the text in certain background color, and to provide a clear text to the user, the contrast ratio should be at least 4.5 to 1, and a slightly lower ratio requirement for larger text. And for Flutter, because we are UI framework, so we cannot just force the users to say, hey, you just can't put red text on green background. Because we are UI framework, we give the developers the freedom to do whatever they want. But the way we handle it is like we have a guideline text in Flutter side. So if the developer run their app towards those guideline tests, and the bad case would usually be catched. And this is an example of font size. So the problem of font size is if you only test your app in default font size, it may look ugly or chopped or unable to read in big font size. The way people change font size is you go to your form and you go to settings, and you can increase the font size to be like 2x. And so we basically get those settings from the OS setting, no matter it's iOS and Android. And the developer should test their app not only on default font size and also on big font size. And the third one I want to mention is tab target size. This one is like if this widget is a tab target, like if you can tap it or long press it, the size should be at least 48 to 48 on Android, and 44 to 44 on iOS, and web standard is also 44 and 44. This is because if your tap touch target is too small, it may be too hard for user to tap on it. The way we do it in Flutter is if it's our default button, we will make sure it meets the standard. And the way we do it is like, okay, if this widget, you can see the second example, it's too small, then we will add some padding around it to make sure the actual touch target is bigger than the visual layout. So when the user interacted, it will fit the accessibility standard. But there's also, because we are a UI framework, so developer can build their own widget. And when they build their customized widget, they may not meet the accessibility requirement. So if you do that, you should also like test your app against the Flutter guideline test. And if you do that, it will try to catch the tap target violation. Also, as I mentioned, the standard is different on Android and iOS. So we have, in Flutter, we have different widgets like material widgets and Cupertino widgets, and then we apply on different standards on them. And then there are other accessibility requirements, like videos should have transcripts. So if the user can't or don't want to watch the videos, they can read the text instead. And there's also keyboard focus traversal, which is like when you are on a web page, you can use the tab key on your keyboard to navigate through all the widget elements that you can interact with. It's different than accessibility focus because even if you don't turn on the accessibility mode, you can still use the tab key to navigate through the elements. And the third one is single gesture alternatives. That means if your app have like a very complicated gesture, you should also provide a simple gesture to achieve the same function. The fourth is images must have labels. So when people with vision impairment to read the app, they can get the context even if they don't see the images. Then I will move on to talk about assistive technologies. There are usually two types of assistive technologies. One type is vision support, but it's basically screen readers. So if you turn on the screen reader on your phone, it will help you navigate through all the elements on your phone and try to announce every element on it. The second part is mobility support, which is basically like provide another source of input instead of just tapping on your screen. I will first mention the screen reader. If you work with accessibility, I think screen reader is like a major part, like a very important part. So if you turn on the screen reader mode on your phone, it will be a highlight rectangle on the current element, and you can use your gesture to either tap it or go back and go to the next focus. So the user get gesture, including like you can swipe left and right to move focus, or you can use 2 finger swipe to scroll, and double tap is tap, and you can also double tap and hold to do the long press. And for the mobility support, there are switch control and voice control. For switch control, it's basically attach another physical button to your phone. And for voice control, it's usually you just tell the screen to do something. Like if you turn on the voice control mode on your phone, you can say things like, tap this cancel button or show number for all the buttons, and then tap the third button or the fourth button. So they are basically different way to input. Yeah, so, and then I will move on to talk about the Flutter framework code. To do that, I want to first mention the Flutter architecture, because we all know that Flutter is a multi-platform UI framework, which is very important for accessibility, because that means we need to support accessibility in different platforms. We need to support them on Android, on iOS, and on web. That requires us to use different native API on different platforms. But the framework code Dart is all the same. So I need to first mention, hey, there are basically 3 layers of Flutter code. There are framework code, engine code, and embedder code. So if you are a Flutter developer, you would be mostly familiar about framework code, which is like entirely in Dart and widgets and stuff. And embedder code is the part that's platform specific, and we need to implement different platform call for different accessibility requirement. And engine call is like an engine layer is like in between them and doing the communication. And then I will first talk about framework layer and all the widgets. If you work with accessibility, you would mostly interact with semantics widget. Semantics widget is a widget that annotated the widget tree with semantic information. I listed a bunch of parameters of the semantics widget here. It can add a lot of things like label, like if it's a button, like if it's a container, if you can block user action, text field read only, focusable. There are a lot of parameters, so I guess I only like copy paste half of them here, and then I want to briefly mention how to use semantic widget. Like the example on the left is you have an image widget and you want to we want it to have a label in semantics. So you can just simply wrap it with a semantic widget and you add a label to it. The second example is how to use live region. So live region is a parameter that basically says, hey, if anything is changing in this region, you should announce it. And the way you can use it is like you also wrap the child with semantic widget and you set the live region to true. And then every time the label here gets updated, it will announce. The third one is an example of how to, if you have like a customized widget and you want to add semantic info to it, like instead of using a button widget from material library or Cupertino library, you instead build your own button. And then in that case, you can add a semantic layer to it. You can set the button to true and the container to true and add a label. It will basically work the same as a button from material. I will go to the next slide. Yeah, and then this is another widget that related to accessibility that I want to introduce. It's called Merge Semantics. Merge Semantics, it will merge all its children into one single node. This is useful if like there are a lot of complicated widgets together on the screen, but you want them to be treated as one single node to screen reader, and you can just combine them by merge semantics. And this is another special widget you can sometimes use in your app if you want some part of widget to be completely ignored by the screen reader, you can just wrap them in the include semantics and it will disappear from the semantic tree. And then I want to talk about trees on the framework layer. So on the framework layers, we have widget tree, which is the tree that most Flutter developers are mostly familiar with because we work with widgets every day. But if you don't work with accessibility, you may not be familiar with semantics tree. But today I'm here to talk about how we generate a semantic tree from the widget tree and how the engine and the platform finally understands the semantics tree as a native accessibility tree, because that's what a native OS would understand. So first, I will talk about how on framework a widget tree will generate a semantics tree. So on framework side, there are 4 important trees. There's widget tree, element tree, render object tree, and semantics tree. So basically, one generates the next. This is debug dump semantics tree. So even if you work with accessibility tree and you want to show what's the current semantics tree for the current widget tree, you can press Shift and S when it's a keyboard shortcut when you are doing Flutter run and running a Flutter application. You can do that and dump the whole tree. Also, you can add the debug dump semantics tree in your test code to see the semantics tree. It will be helpful. And first, I will talk about so widget tree is a tree that we are mostly familiar about. So basically, it's widgets inside another widget, and we nest them. For example, we can put two texts in a scaffold and then in a material app, and the widget tree will generate an element tree. An element tree mostly manage things like life cycle and build context, and then it will generate a render object tree, which it will figure out how the layout and then how the rendering works. And eventually the render object tree will give us a semantics tree. And I will talk about how the render object tree generates the semantics tree. So in a render object, there are three important semantics related functions. The first one is called describe semantics configuration. And the second and third is assemble semantics node and visit children for semantics. So basically, a render object would have a piece of semantics information, and describe semantics configuration is this function to say, hey, what kind of semantics information do we have on this certain render object? The second one, the third one is used less. They are used to they are like used to say, hey, I have those children. How do I assemble these children in the semantics tree? Because it might look a little bit different in the render object tree. So these are some semantics configuration in a render object. We have some basic properties, and we have some semantics actions, we have some semantics rows, and there are also some formation related parameters. They come from things like merge semantics or exclude semantics. So it will affect how the shape of tree works. So the semantics trees might be eventually much more smaller than render object tree, because a lot of widgets and a lot of render object, they do not contribute to the semantics tree. You could have like an alignment and a center widget. They don't have a semantic information in them. And there are a lot of widgets like a column and they do not have a text in them. Or like there are two nearby texts, they can actually be combined as one semantics widget. So we will do a lot of merging when we generate a semantic tree from a render object tree. Multiple pieces of information will get merged into single semantic node. So this is how we do the merging. So on the left, we have a render object tree. And how we do the merging is we try to merge from the bottom to the top until there are conflict saying, hey, these two render objects could not be merged into one semantics node. And the way we do it is we track the conflict. How do we track the conflict? Is we check all the semantics flags. There are things we consider. There are things we consider are conflicts, and there are things we consider that they are not conflicts. For example, we can merge text with text. Like if we have this text which is saying A, and then we have another text which is saying B, we'll merge them, then they will become A and B. And but if there are two bottoms, we know that these actions cannot exist on one single semantics node. We will not merge them. And there are also explicit child node, which is something you can set in a render object. If you set that to true, it's basically saying, oh, I do not want to merge any child node of me, so they will become their own semantics nodes. And there's also a parameter called a semantics boundary. This is basically saying, hey, do not merge me with my parents. So in that case, it will form its own semantics node, but its sibling can still merge with the parent. Yeah, so that's basically all I mentioned about the framework side. I mentioned about there are 4 trees. The widget tree is with the one we are most familiar about, and then it will generate element tree and rendering tree, and eventually we will get a semantic tree. And then I talked about rendering object has this describe semantics configuration. It's where the semantic info are stored, and it's essentially how we generate the semantics tree. And then I talked a little bit about the merging logic and how we use this merging logic to finally generate the semantics tree. Yeah, and then I want to talk about the platform and how platform communicate with framework. So we know Flutter has different layers, and the framework layers works the same on Android and iOS. So the problem is how we eventually translate this framework semantics tree to something that OS can understand. The way we do it is we have different platform embedded on each platform, and we need to communicate between framework Dart code and the platform code. So the way we communicate is we communicate on both sides. So on the OS platform side, we may get some state changes. And on framework side, we also get some state changes. And on platform side, we will get changes like, hey, this user just turned on the screen reader. This or like this user just turned on the high contrast mode. And from the framework side, we will update the UI, and so the framework tree will also be updated, and we need to tell the OS, hey, this app semantics tree is updated. And there are also accessibility event from the platform to the framework, which is basically like, hey, the user tapped this semantics node. So for platform originated state changes, there are sometimes user enable or disable or accessibility features, and sometimes there are accessibility events. So we have this function called set semantics enabled, and we have this function called set accessibility feature. Yeah, and this is how we pass the information from the platform to the framework, and this is how we pass the information from framework to platform. The most important one is called update semantics. So we don't send the whole semantics tree every time something changed to the platform. We send them the delta. We send them, hey, this 3 node is updated. This is for performance reason. And I added some code link here. It's in the platform view and the semantic node. And this is a picture of like what happened when semantics is enabled. So the platform will tell embedder, and it will tell the engine, and we have like semantics bounding in between, and it will tell the rendering boundary, and finally it will tell the render tree on the framework side, hey, the semantics is enabled, because semantics tree is the optional tree. It's not like rendering tree, it's always there. We only generate the semantics tree when the user turn on the accessibility mode. And this is what happened when the UI is updated. So this now the information is passed from framework side to the platform side. It will go through the rendering tree, and it will go through engine to embedder, and finally to platform. And then I will talk a little bit about what's happening on iOS and what's happening on Android. First, what's happening on iOS? How do iOS assistive technology work? iOS queries this thing called UI view and called this thing called accessibility elements. And for Flutter, we need to provide these accessibility elements that iOS can understand, because it does not understand Dart, right? So we have this accessibility bridge to translate information from the framework side to something iOS OS can understand. And we do it in our accessibility bridge. In accessibility bridge, we will keep a UI accessibility tree, and we also produce UI accessibility notification, and we forward accessibility events. So what's a UI accessibility tree? UI accessibility tree is like the iOS version of Flutter semantics tree. OS can query property from like accessibility label and its accessibility element from the UI accessibility. And it also have things related to semantic rows. So on iOS, there's this special thing. There's a special thing called UI accessibility container. They have this rule, and a UI accessibility container can't be a element and a container at the same time. It's different than the logic from the Flutter framework. So we will try to make our tree in a different shape, but so it will still achieve the same function, but the tree function will, the tree shape will be slightly different. So on the left hand, we can see a semantic tree from the Flutter framework. It will eventually be converted into a UI accessibility tree in iOS. Yeah, this is basically another example of how a semantic tree on Flutter framework side would look like on iOS side. So we do this converting on our accessibility bridge. So eventually, a semantic tree from Flutter framework can be read on iOS platform. And then I will talk about Android for a little bit. So Android have their own version of similar stuff. They require this thing called accessibility node info, and we need to implement this thing called accessibility node provider. We also have a accessibility bridge for Android. It's doing the same thing, doing the similar thing as iOS. Basically, translate the framework side tree to a tree that OS can understand. So it will implement the node provider. What does the bridge do? It also keeps a tree, but this time for Android, and it produces some accessibility event for scrolling and view focus and stuff, and it forward accessibility actions. So this is a Android version of semantic node, and we use create accessibility node info to create this Android version of semantics tree. And Android also have their version of semantics rows, and it's basically set on set class name. And Android does not have the weird rule that a container can't be an element at the same time, so the tree will eventually look as the same shape as a Flutter framework tree. Yeah, that's all I am gonna talk about the Flutter code base today. Then I will move on to talk a little bit about accessibility testing. So for testing, first you can do manual testing. It's basically turn on the screen reader mode and you can swipe and try to use the app on screen reader mode and on other different mode like switch control and voice control. There are also Flutter guideline testing. As I mentioned before, you can test things like color contrast, tap target in Flutter. And this there is also debug dump semantics tree, which is you can either use the keyboard shortcut when you are running a Flutter app to see the whole semantics tree, or you can add this in your testing code. It's helpful if like you think the semantics tree should look like this, but it actually looks like that and it's different. And you know why it's different. And the fourth way is like there are other native OS scanners for iOS and for Android. And I will talk about how Flutter team handle accessibility. So we have our OKR planning, and on each OKR planning, we will talk about what's the next accessibility feature we are going to work on, and what's some project related to accessibility team. And we have our weekly triaging, and so every week we have this meeting to triage all the issue that's labeled accessibility team, and we will do the PR review. Yeah, so basically that's it, and we always welcome new contribution to our report. Yeah, and that's yeah, this is a final release checklist. When you are publishing your Flutter app, you should check the screen reader testing, check the contrast ratios, the tab target, and you should also check text font size. Yeah, that's it. Thank you for hearing my talk and thank you for caring about accessibility. Yeah, if you guys have any question, I can try to answer.
Thank you so much, Hannah. So let's look at the questions. So right now I am going to stop recording so that we can be a little candid. So